Hello, my name is Karan. I'm a first year CS major. My pronouns are he, him, his, and the top two courses I'd like to tutor are CS24 and CS32. I'm really excited to be a ULA because in the past I've really enjoyed teaching. I was part of a group of students that tutored AP Calculus AB, assigned by our AP Calculus BC teacher in high school. And also for the past year, I've been working part time as an instructor for Kumon, and I've been teaching things like reading and mostly math to students from first grade all the way up to high school. And I've really enjoyed that experience, and I think a lot of that will transfer over to being a ULA, and I'm really excited. So for the topic today, I'm going to be talking about chained hashing. So let's start off with a little bit of a review of hashing. So hashing is pretty much just a method of storing data in a list or an array, and in which we're given a unique key for every element that we're storing. And this key is pretty much going to be the input for our hash function. And what the hash function does is it provides output. What the output of the hash function is going to be the index that we're going to be storing this in some array or list. So we have some x, and this x is going to be unique for every element. It can be an integer, it can be a string, it can be anything. And that is going to be the input for this h of x, which is the hash function. And the output is going to be the index that we're storing it in. So I'll give you an example just so you can understand. Suppose we have an element, and it'll have some data that we're storing, but we'll also have a key, and we can just say, suppose this key is 6. And a simple hash function I can give you, the hash function can be anything. This one's just a simple one. Let's just say x mod 5. So this just means modulo 5. So this just means that the remainder when you divide by 5, the output, that's going to be the output. So in this case, when you divide 6 by 5, the remainder is 1. So we're going to be storing this element with key, we're going to be storing this element with key 6 in the first position, because h of 6 is 1. Another one, let's do, is 8. And this will obviously, the 8 is not necessarily the data, this is just the key that is going to be storing. This is just the key that's associated with this element. And h of 8 is 3, since that's the remainder, so we're going to be storing this element in the third position. And the reason this is useful is we're pretty much just trading space for time. You can see that it's really easy to search for a specific element because you just need to take the key of that element and pass it through this hash function, and you immediately get the index that is stored in. But the reason it's only on average is because of this problem that we get called collision. And this is pretty much just when you have a different key that when you pass it through the hash function, you get the same output. So it pretty much you're getting what's the word I'm looking for? An occupied output. So I'll give you an example here. Suppose we have an element with key 11, and h of 11 is 1. Because when you divide by 5, you get 2, remainder 1. And you can see that's already been occupied by this element with key 6. So solving this problem is what we're going to be doing today with chained hashing. But chained hashing isn't the only way of solving this. You can see there's many ways of doing it. These are some of the common ways. One of them is open addressing, in which we just traverse the list for the next unoccupied spot. Another one is double hashing, in which we can have a second hash function like g of x, and in the case of a collision, we use g of x instead of h of x to find the position. And the third one, which is what we're going to be talking about today, is chain hashing, and I'm going to be going over that in detail. And all of these have their advantages and disadvantages, and you just used whichever one is best for your situation. So in chain hashing, each index in the array corresponds to a sublist of elements with the same hash value. So any elements that collide will be chained to this sublist. And this sublist can be implemented in a number of ways. A common way is using a linked list. And the advantages of this is that it provides better performance for inserting data. It's always O of 1, which is not necessarily true for all the other methods. It also guarantees the hash table does not fill up, which is also not necessarily true for the other elements. And it's also relatively simple to implement. Something you do need to note, though, is that it does use up a lot of space, and in the case of a very long chain, the search time can approach O of n, which is obviously not ideal. So here's how it works. Suppose we have a key. Let's just say the key here is, one second. So let's just say the key here is 7, and let's use the same hash function. So x modulo 5. You can see here that'll go to 2. So instead of just storing it directly in that data will correspond to this index will correspond to a linked list, and the data will be stored in here. So let's have another one. You can just say is 6. H of 6 is 1. So when you go to 1, there will be another linked list there. Oh, sorry, I don't need to draw that. And you can keep doing this with how many ever elements you want. And let's just say we have a collision, so the same collision as last time. Let's have 11. And in this case, what it does is it just chains it to the end of this linked list. So it'll add another element to the end of this linked list, and that's where it'll be stored. So if you're trying to search for 11, you will pass it through the hash function, you'll get 1, and the code will just traverse through this linked list until it finds 11. And you can do this as many times as you want. You can see here you have a bunch of sublists within your array. So that's it. I went a little bit over time, I'm sorry. If this is where I'd ask if you have any questions. And I'd just like to thank you guys so much for considering me for this position, and I hope you guys have a great day.